Good afternoon, everyone. My name is Ania Khodabakhshian, and I'm a PhD candidate at Politecnico di Milano. And on behalf of our research team, I will represent our research titled Data-Driven Framework to Select Best Retrofitting Strategies. So, as most of you might know, the status quo of the building stock in European countries, especially Italy, is not in a promising kind of condition. In general, building stock is responsible for high portion of CO2 emission and also energy consumption, wasting a lot of energy and capital. So this is the current status, and though European Union has so many goals like decarbonization goals or EU Green Deal in order to make the engagement in retrofitting projects more, still the rate is very, very low and is not in a good status. So all of this resulted in gathering information on national and international level through national databases, like the ones we have in Italy, the CENED database and like TABULA, but most of the time these databases are left as is, and no practical use and no kind of information extraction is happening at this moment to deliver some tangible results out of that. So in general, what motivated us for this research was that, okay, we have this situation and we also have some useful information, what we can do now. In general, retrofitting is proven to be very useful in different kind of directions. It could be seismic, energy retrofit, single case-based models, or like on urban scale level. We have different types of them. But specifically, we're focusing more on the energy retrofit at this moment because the databases we have are more related to that. And it includes different interventions. It could be like installations and change in the building materials or the building envelopes or the heating systems in order to make it more energy friendly. But the point is, most of the conventional retrofit models proposed and presented in the literature are implanted on case studies, single case studies. And they're most of the time engaged with the complexities of the problem. So if you're not an expert in the field, you can hardly understand how it works and you can hardly implement it to new cases. And it's not applicable and scalable to huge databases. And they have high cost of data acquisition. Data is not just easily accessible. So we came up with the idea, okay, we go with the data-driven methods. So there are basically three main kind of directions for the data-driven methods. The BIM, multi-criteria decision-making. Both of them are very useful, but still, when we're talking about a portfolio of millions of projects, millions of cases, it's not really easily scalable and applicable to those. The solution that we came up with at the end was the artificial intelligence in order to detect patterns and extract insights from huge database that we have. And it usually functions very well in uncertain and dynamic and complex environments like the building stock. So what made the application of AI much more trending at this moment is the accessibility of the big data in the industry, and like we have different digital technologies to produce this data and to collect this data and to use those. So why not using it also for the retrofitting projects? So in Italy, we have two main building databases, the CENED, which includes the building energy performance data, geometric data, and also installed technologies data, and also TABULA, which is like the national scientific report on the building stock and the building elements and associated energy-related metrics to those. So the main idea, the main goal is to connect these two databases through AI and to understand how we can use AI to extract insight from these two databases and to distinguish the current materials of the buildings based on their energy performance metrics and what is the desired materials to achieve a better energy performance. And by comparing these two, we can understand what the retrofitting strategies could be. So this is an ongoing research project. So in this presentation, I will present till the area of the understanding the retrofitting scenarios. But basically what we do, we use the CENED database. We did the clustering and distinguish different clusters of buildings based on their construction period and also their energy label and the thermal transmittance value of the windows, walls, and roofs. And we did, based on this, we did the matching with the tabula to understand, based on this thermal transmittance value, what could be the materials, and then compared to the current status and to the desired status to see how the materials should change and what the retrofit scenario should be ideally. In the future, obviously, we will do other stages to calculate the energy saving, calculate the cost related to this retrofitting, and understand the cost-benefit analysis of the retrofitting strategies that we're proposing. But today, we're remaining in this scope. So after the data cleaning of the CENED database, which had 1.5 million records, we remained with 900,000 records, which were categorized in 7 construction periods and 8 energy labels, in total 56 groups. And this is the heat map. You can see that most of these buildings were built before 1930 and with the energy label of G, which is very not promising. And through the clustering, in order to group these buildings under the clusters with the same energy performances and energy characteristics, we used these common features, which are like the energy label, the U values, the primary energy for heating, in order to group these buildings under clusters with the same characteristics. So based on that, as you can see, for example, this is the clusters of the buildings built between 1993 and 2006 with the 4 different energy labels, G, A plus, and F. And you can see within each of these groups, we might have different clusters based on their U value of the window, U value of the wall, and U value of the roof. So when we compared those, we understood that the clusters within the same construction period, but with a better energy performance, had different U values, which means if we're, for example, in an interval of between 1930 to 1960, this is the construction period, the buildings that have the energy label of G and the buildings that have an energy label of A, if we compare them, basically it means like those that have the energy label of A are those already retrofitted. That's why they're performing better. They have a better energy label. And that's why their U values are lower after the analysis of the clustering that we did. Therefore, if we compare these two clusters, we would understand what the result of the retrofit would be and the materials should be. So for each cluster, we assigned an I value, including 3 numbers of U value of the wall, U value of the window, and the roof. And using this, we compared that, as you can see, this is, for example, the clusters within each of these groups. We compared that to the Tabula database because there, the building materials are categorized based on their construction year and their U value, the thermal transmittance value. So for each building cluster that we have, we can understand that, for example, initially, it was a hollow wall brick masonry, but then if you want to reach from a lower energy label in a cluster in that energy label to a better cluster in a better energy label group, we can see the difference of the U values and we can see what materials they are made from. So comparing these two, we can understand what the retrofitting scenario and strategy should be like. And this is again like a comparison between a cluster under the G energy label and a cluster under A energy label. and what are the differences between their U values of wall, window, and roof, and what are the material differences. So in conclusion, AI is a very useful tool, but we should understand on which framework we're using it, and not just using it sparsely in different single case studies, but to have a systematic approach and to use that in order to use the knowledge already existing in the databases, to extract knowledge from them, and to help us in our decision making and help the policymakers to make the proper decisions for the retrofitting of the building, which is very important and very crucial at this very moment in Europe. So thank you so much for your attention. These are my contacts, and I would love to hear your questions or suggestions, everything. Thank you.